Imagine a tunnel stretching across the cosmos, a shortcut through space and time. Bending reality itself, a hidden bridge connecting distant galaxies in an instant. Could such a phenomenon exist, or is it merely the stuff of science fiction, confined to movies and novels? Welcome to the mind-bending realm of wormholes. Cosmic mysteries that challenge everything we know about space, time, and the universe itself. Today, on Cosmic Horizon Hub, we're diving deep into one of the most fascinating questions in physics. Are wormholes real? What if the universe is hiding doors to distant worlds, or even different times right under our cosmic noses? Let's unravel this enigma together. First, let's start with the concept. A wormhole is, in the simplest terms, a bridge, a tunnel through the fabric of spacetime that could, in theory, connect two faraway points in the universe. Imagine space as a sheet of paper. Normally, to go from one corner to another, you'd draw a straight line, a long journey across the page. But now, imagine folding that paper so the two corners touch. A wormhole is like poking a hole through the folded paper, a shortcut. That could reduce a light-year-long voyage into something instantaneous. The idea sounds fantastical, almost laughably impossible. But it comes directly from the equations of general relativity, Albert Einstein's monumental theory that reshaped our understanding of gravity. In fact, the notion of wormholes traces back to Einstein himself, alongside physicist Nathan Rosen, who in 1935 proposed the concept of Einstein-Rosen bridges. These bridges weren't initially imagined as practical cosmic highways, but rather as a mathematical consequence of general relativity. Yet, the equations suggested that, under the right conditions, a connection between two separate regions of spacetime could exist. Think of it like a cosmic tunnel carved not by diggers, but by gravity and the geometry of the universe itself. But here's where things get tricky. Theoretically, a wormhole could exist, but it's not just about bending space. It's about stability. The equations tell us that a typical wormhole would collapse the instant anything or anyone tried to pass through it. Picture a tunnel made of jelly. If you put your hand inside, the tunnel squishes shut before you can move. To prevent collapse, physicists propose something called exotic matter, a hypothetical substance with negative energy density. This isn't matter as we know it. It's a strange form of energy that would push outward, holding the tunnel open against the crushing force of gravity. Without this exotic matter, any wormhole would pinch off before we could even step through it. Now, negative energy might sound like pure fantasy, but physics offers glimpses of it in the real world. The Casimir effect, a quantum phenomenon observed in laboratories, demonstrates tiny amounts of negative energy between two metal plates in a vacuum. Could this be a hint that exotic matter isn't entirely impossible? Perhaps. But scaling this up from microscopic experiments to a stable, human-traversable wormhole is a cosmic leap so vast it boggles the mind. It is like trying to build a bridge over the Pacific Ocean using nothing but grains of sand. Despite the challenges, wormholes remain an active area of research. Some physicists even explore traversable wormholes, theoretical models where the geometry of spacetime and exotic matter work in perfect harmony to create a stable passage. These aren't sci-fi dreams. They're equations, simulations, and hypotheses. Imagine a cylindrical tunnel stretching through the universe, shimmering with gravitational energy, its throat held open by physics we barely understand. Step inside, and you could emerge in another galaxy, or perhaps another era. The implications are staggering. A wormhole wouldn't just be a cosmic shortcut, it would challenge the very notion of distance, of time, of cause and effect. But if wormholes exist, why haven't we seen one? Part of the problem is scale. The universe is unimaginably vast, and wormholes, if they exist, could be rare, tiny, or hidden in extreme environments like the regions around black holes. In fact, black holes themselves might be the cosmic anchors of wormholes. Some solutions to Einstein's equations suggest that the interior of a black hole could connect to another point in spacetime, a wormhole, cloaked in the darkness of gravity so intense that light itself cannot escape. Yet the same equations also warn that such a structure would likely be unstable, collapsing before anything could pass through. The paradox of wormholes is that the universe might allow them but simultaneously conspire to keep them forever out of reach. Interestingly, modern physics has even flirted with the idea that tiny, microscopic wormholes could be sprinkled throughout space, remnants from the birth of the universe. Quantum foam, the turbulent, frothing structure of spacetime at the smallest scales, might be teeming with minuscule wormholes popping in and out of existence. These aren't highways for humans. They're ephemeral bridges, flickering like sparks in the cosmic fabric, influencing particles and forces in subtle, almost undetectable ways. Could these tiny tunnels be connected to phenomena we observe in quantum physics? Some theorists suggest links to entanglement, the spooky action at a distance that so puzzled Einstein, hinting that the universe might be more interconnected than we can perceive. Then there's the tantalizing connection to time travel. If a traversable wormhole could exist, the equations allow for the possibility of moving not just through space but through time. By manipulating the mouths of a wormhole accelerating one, relative to the other time dilation effects from relativity could, in theory, create a bridge into the past or future. Suddenly, wormholes aren't just cosmic shortcuts. They're potential time machines. Imagine the consequences: visiting distant epochs, witnessing the early universe, or even returning to moments in our own past. Of course, paradoxes loom large. Could you alter history? Or would some cosmic law prevent such interference? The answers remain firmly in the realm of speculation, but they fuel our imagination and drive physicists to probe deeper. Despite the allure, wormholes face significant hurdles. Energy requirements alone are astronomical. The amount of negative energy needed to stabilize a macroscopic wormhole could rival the total energy output of a star, or even a galaxy. And then there's the question of causality allowing. Time travel could potentially violate fundamental principles of physics, creating loops and contradictions that the universe might actively forbid. In other words, even if wormholes are mathematically possible, the universe might have built-in cosmic speed bumps to keep reality consistent. Yet scientists are undeterred. Advances in quantum gravity, string theory, and general relativity continue to offer new insights. Some proposals even suggest that wormholes could leave observable imprints in the universe. Subtle distortions in light from distant stars, gravitational lensing effects unlike any black hole, or peculiar signatures in cosmic radiation. Detecting such signals would be revolutionary, confirming not just the possibility of wormholes but opening a new frontier in astronomy. The idea that we could observe a doorway to another galaxy or even another universe is exhilarating. Wormholes also captivate the public imagination because they blur the line between science and science fiction. They appear in countless movies, TV shows, and books, often as dramatic portals for interstellar travel. While Hollywood exaggerates their stability and accessibility, these portrayals reflect a deep human desire to explore, to shortcut the vast distances of the cosmos, to defy the tyranny of time. Wormholes remind us that the universe is stranger than our everyday experience, that the cosmos holds possibilities we can barely fathom. Some recent research even explores analogs to wormholes in laboratory settings. Scientists have created systems where light or sound behaves as if traveling through a wormhole, bending paths in ways that mimic theoretical models. These experiments don't produce real cosmic tunnels, but they allow physicists to test predictions about how wormholes might interact with energy, matter, and information. Each small experiment brings us a step closer to understanding whether these cosmic shortcuts are purely mathematical curiosities or a hidden feature of the universe. So, are wormholes real? The answer is both tantalizing and frustrating. We don't know. The mathematics says they could exist. The physics suggests ways they might be stabilized. Observational evidence is elusive, and the energy requirements are staggering. Yet, the possibility lingers, whispering to us through the equations and experiments, daring us to imagine. Even if a practical, traversable wormhole remains beyond our reach, contemplating them reshapes our understanding of space, time, and reality itself. It forces us to confront the limits of human knowledge and dream bigger, stretching our imagination across the cosmic canvas. As we peer deeper into the universe, seeking faint signals and testing the boundaries of physics, wormholes remain a symbol of the unknown, a reminder that the cosmos is far more intricate than we perceive. Perhaps one day, through a breakthrough in quantum gravity or an unexpected observation, we'll glimpse the shadow of a wormhole, a doorway shimmering in the fabric of space-time. Until then, they exist as both a challenge and an inspiration, a riddle written into the very structure of reality, waiting for curious minds to unlock its secrets. And here's a twist to leave you pondering. Some theorists propose that every black hole could hide a wormhole on its far side, leading to a parallel universe or another corner of our own cosmos. Could the universe be threaded with hidden tunnels, invisible to our instruments, silently shaping the flow of energy and matter across unimaginable distances? If true, it would mean that the vast empty stretches of space we see are merely the visible tip of a hidden cosmic network, a web of shortcuts linking the stars, galaxies, and perhaps even the very fabric of time itself. So, the next time you gaze at the night sky, consider this. The twinkling stars may be more than distant suns. They might be entrances to unseen pathways, gateways to the universe's secret highways. Wormholes, whether real or imagined, invite us to dream boldly, to question the limits of reality, and to marvel at the incredible possibilities woven into the cosmos. If you've ever wondered what it would be like to step into a wormhole, to emerge on the other side of the universe, or even in another time, share your thoughts in the comments below. Could humanity ever harness such cosmic shortcuts? Or are wormholes destined to remain the domain of imagination and theory? Don't forget to like this video if your mind is now spinning with the possibilities, and subscribe to Cosmic Horizon Hub to continue exploring the mysteries of the universe with us. The cosmos is vast, strange, and full of secrets, and together we'll journey to the very edges of understanding.